Hello everyone. Today I am going to talk about another assessment or another project that I did. Okay, this is the template. This is the first time I made 10 template, so it's a little bit messy and I don't know I did good thing or bad thing. Okay, I will discuss about it, and this is my report where I did all this analysis. It's all the analytical analysis for the for your information. Okay, it's like the calculating your formulas, like values from formulas using different inlet input values. Okay, this is my report where I calculate all the things. Oh, okay, this is the main model. So let's talk about our poster. Okay, it's look kind of good there, and I did tribological analysis on the Royal Enfield bike where I used the specific parameter for this bike, and I input the different velocities, different force, and calculate how it acts, how much friction it will get, how much wear it will get. Okay, so tribology is crucial parameter for evaluating performance and reliability of motorbikes where friction and wear are inevitable at the pad and disc interface. So I did the analysis to calculate the friction force, torque, brake pad wear. Okay, at different speeds at 30 km per hour, 50 km per hour, 80 km per hour. Okay, using the different force like 1500, 3000, 5000. So finding shows that brake torque increases linearly with the clamp force and also the wear. So even brake torque is good for us, but it also increases the wear. So we have to know that we don't apply the excess pressure which lead to excess wear. Okay, so for the introduction I inputted this uh, diagram for the disk from my own design. So what is the function of brake disk? It convert kinetic energy for through the friction to stop the vehicle, okay, into the thermal energy. I got to know that it's a high contact pressure and sliding velocity strongly affect the braking torque. And from the different literature, I got to know that bound material roughness, material hardness, contact pressure vary the friction and wear in the material. Okay, and I made the my Excel model. Okay, I got the formulas for torque, velocity, volume, wear depth. Okay, this is only Excel model, analytical model. So this is just a case study, as you can say. So first of all, I input my values like the speed and climb force, and I calculate the friction, brake torque, sliding velocity. Okay, and I got the wear, and this is my model. Okay, as you can see that this is the inlet parameter, input parameter, and I calculate for the different speed. From figure, we can know that wear depth is increasing with the force. Okay, with our clamp force, if we apply the more force, okay, we will increase the wear depth, which is not good for us. Okay, but it's also increase braking torque. As the speed increases, the wear depth is also increasing. As you can see, it's maximum. Okay, so it shows that in the conclusion, brake torque significantly increases with the clamp force, which includes the braking force. However, wear analysis indicated that increase in the clamp force also led to acceleration of brake pad due to high pressure in contact pressure. So friction power analysis is a high speed. Display the high speed cause high speed friction heat generation affecting the braking performance. To design the best braking pad or braking system, we need to use the wear resistant, thermal resistance material. Also, we need to use like the ventilated, cool down the system. So we need to think about the other thing. It shows that how the wear and friction vary with the input parameters. So this is the normal study using the analytical model to know the tribological performance of this model. Okay, thank you.